Hello, squad. Today I want to teach you how to change an equation from slope-intercept form into another form you commonly see called standard form. So if you would, make this the title on the next page in your math notebook, and when you have done that, close that up. Turn off and clear out any distractions. Give me access to 100% of that brain power for the next few minutes, and off we'll go. All right, slope-intercept form, man, handy. Probably a little angry with me for not teaching you before. Like back when we first started dealing with equations, if I gave you an equation and asked you for a graph, you had to do this very carefully. It was a lot of math, and then you had to make it into the graph. And you had to find the slope, you had to find the y-intercept, and do a lot of work. And then it turned out you could do this much easier if you knew your y-intercept, and that your slope was a y to x ratio. X would change by 3, and you can just like so quickly make a graph. It's a great form, slope-intercept form. And I want to remind you of a big idea from a while ago, separate from that right now. One variable in them instead of equations that have two variables in them. We would do the same operation to both sides to make them easier to deal with. So when you look at, say, this equation here on the left, 3x minus 16 equals negative 10. From there, we would try to figure out what is x in that equation. And it's hard to just common sense your way to that. Like, is it 1? Is it 2? Is it negative 1? Is it negative 2? And when you look at that equation, not so easy. So we did things like figure out both sides, do the same thing to both sides. This goes away. This becomes 6, and I end up with 3x equals 6. And that is very easy to find the solution of. That is x equals 2. Right? And if x equals 2 in this equation, then x equals 2 in this equation. And so we could do things to make an equation simpler to solve by doing the same thing on both sides. We're going to kind of use that idea today too. I already did that on the last page. So we're going to use this big idea to change from equations from slope-intercept form to another form called standard form. Here's slope-intercept form. You're very familiar with it, right? Here are some features of it. Y is on a side all by itself. All alone, I'll say. Right? Y is on one side of the equal sign. Everything else is on the other side of the equal sign. There's nothing with the Y. Y also has no coefficient. Right? We've never run into one where it was like 4y equals 3x plus 5. That's not slope-intercept form if y has a coefficient. It's just y by itself. And then we know the coefficient of x is the slope. Coef of x is the slope. And the constant is the y-intercept rather. So that's slope-intercept form, super nice. Standard form looks like this. This is a different equation. It's not equivalent to this one. The standard form looks like this. Some differences are, you'll notice the x and the y are on one side together, and the constant's on the other side by itself. So it's a different way to set up a linear equation, and that's it. So some features of it, like I said, x and y are together on one side. Slope-intercept form, they're not. Y is on one side, x is on the other. Constant is alone on the other side. And you'll notice too, y might have a coefficient now. It might not. Today's examples are not going to. But y might have a coefficient. And that's different as well. So slope-intercept form, you have y equals x is on the other side with its stuff. Standard form, the x's and the y's are together on one side, and the constant's alone on the other. So what we're going to do today is change this to standard form. It's in slope-intercept form now, and we're going to change it to standard form. Remember, standard form means the y's and the x's are together, and they equal the constant on the other side. So what I'd really like to do is have these x's be over here on the other side of the equal sign. That would be great because then the x's and the y's would be here and the constant would be left here. So I'm just going to use our same two strategies I taught you to do one operation with and just show you how quickly and easily they switch to another. So if I were to draw this out with my drawing strategy, I would have a y on one side, I'd have 3x on one side, and I would have 5 on this side. And what I would really like to do is move these over there, but that's not a thing I can just do. Whatever I do on one side, I have to do on the other. So my next idea would be, well, what if I take 3x's off both sides? Can't do it. And so the other way I got rid of some things, other than taking it away, is I put its opposite on both sides. I could say, okay, I'm going to put 3 negative x's on that side, because those are going to make 0. Then the constant will be by itself. That's good in standard form. Which is fine as long as I also put the same thing on this side. And now those go away, and I'm done. I'm already in standard form. If I change that back to an equation, it's y plus negative 3x equals 5. Now, this is the slope-intercept form. This is the standard form of the same equation. Standard form. That's one way to do it if the drawing strategy is nice for you. The other way we did this was the inverse operation strategy, we called it. We would write down our equation. And so what I'm going to do now is not a thing I ever did when we were solving for a variable. I was always really focused on figuring that out. What is x? I'm not doing that now. I'm just trying to move that over here. So what I can do is I can subtract it from this side. Then it's not there anymore. That's nice. As long as I also subtract it from this side. What's y minus 3x? I don't know, but I can write it. Y minus 3x, whatever it is, equals 5. And you'll notice same thing here and here. Two strategies. I now have it in standard form where the x's and the y's are together on one side and the constants together on the other. You'll notice a small difference. This one says y plus negative 3x. This one says y minus 3x. Those are the same. Remember, anytime there's subtraction, we add the opposite, and those do come out the same. I'm going to do another one where there is no constant. So remember what we want to do here in standard form is we want the x's and the y's on one side and the constant alone on the other. There is no constant here. So anyway, let's see how this plays out. So I want to change that to standard form, which basically means I just want to move the x's over here, or, doesn't really matter, move the y's over here. Just so long as the x's and the y's are together, will be fine. I'm usually in the habit of moving the x's to the y side, because if we had a constant, it would be on that side. We just don't have one on this one. So drawing strategy is one option. Draw it out, y on one side, negative 4x on the other. And that's it. If I want these on the same side, I can't take these away because there's no similar thing to take away here. But I can add a positive x to each of these that will make those go away as long as I also do that here. So this is all gone. X's and y's together. I like what I see here. 4x plus y on one side equals nothing left on the other side. We have a symbol for nothing in math. It looks like this. So the constant will just end up being 0 sometimes if you don't see one here. It's just how that works. So that's it in standard form. Inverse operation strategy works the same way. If I would like to move this over here, I can't just move it over there, but I can get rid of it on this side. If I add 4x, negative 4x and 4x together make 0, which is great as long as I do that here too. Those are gone. Y plus 4x on that side equals nothing on the other, and I get the same thing either way. That's how you do it. Open your notebook. Let's do a little bit together. So first thing I want to remind you, big idea. In algebra, there's this big idea, anytime in algebra, as long as you do the same operation to both sides of an equation, all the solutions stay the same too. Remember, this was my example before. This one and this one have the same solutions because I can do the same thing on both sides over here and get that. And that's easy to find the solution, just by doing the same thing on both sides. We're going to keep doing that today. We're going to use that big idea that I can just move things around that way as long as I do it on both sides. So, facts to know. First, slope-intercept form. What do you need to know about that? Y is alone on one side. That's the first feature of slope-intercept form. It's always y equals. And there's also never 2y or 3y or negative 5y. So y also has no coefficient. If it does, you're not in slope-intercept form. It has to be y equals like that. Two other things. The coefficient of x is the slope, and the constant is the y-intercept. That's what we know about slope-intercept form so far. Go ahead and pause and write that if you need to. Standard form, there's less to know. The main thing is you'll notice the x and the y's are together on one side. And different from before, y might, I'm going to say might, have a coefficient. We're not used to seeing that in slope-intercept form, but in standard form it might. Other thing to know is the constant is alone on the other side. And that's called standard form. It's not as useful, like this does not tell you the slope, this does not tell you the y-intercept anymore. You don't really get a lot of great information from standard form. There's some nice things you can do with it, which is why it exists in the first place, but it's not as handy. So here's how that plays out. First thing here, y equals negative 4x minus 8. So we're going to turn this into standard form. And to do that, we want to move the x's over to the y's side. So this is by itself on this side, and the variables are all together. But you can't just do that. We've got to do it carefully. So drawing strategy is one possibility. This would look like this. Constant would be negative 8 if I add the opposite. And to make these disappear, I'm going to add 4 positive x's to neutralize them, to kind of make them go away. And that is fine as long as I also add them here. So when I'm done, I end up with 4x plus y on this side and negative 8 on the other side. And that is in standard form. Ta-da! The other way to do it is the inverse operation strategy. What I would like to do is move this over there. So the way I do that is I add its opposite here. So negative 4x plus 4x goes away, make 0. And as long as I add it on the other side too, that's fair to do. And I would get y plus 4x equals negative 8. I don't care which strategy you use, inverse operation or drawing strategy, they both give you the same thing. They're both perfectly fine. They're both just different versions of the same thing to do. Y'all, that is how you change an equation from slope-intercept form to standard form. Hope this made all the sense in the world to you. But it is very, very new. So if you caught yourself zoning out or not understanding anything or trying to write while you worked and not taking it all in, give this a second watch. I promise you'll come to class all ready to go. See you then.